Hello everybody. Today we are going to see about MIPS 32 programming in assembly language. So the first one is the introduction. So we are going to see what it is actually. MIPS 32 indicates it is a microprocessor without interlocked pipeline stages. So it is a 32-bit processor. It has the reduced instruction set computer architecture, that is RISC. It is used for embedded systems due to its simplicity, efficiency, and low power consumption. MIPS processors are used in various devices like routers, set-top boxes, and even in some older video game consoles. The key concepts and components are listed here. The first one is the reduced instruction set computer. The second one is the load store architecture. The third one is the pipelining. Fourth one is the instruction set. And the fifth one is register file. So we'll see one by one in detail. Reduced instruction set computer. So RISC. MIPS is a RISC architecture, meaning it has a smaller, simpler instruction set compared to complex instruction set computers, that is CISC. The simplicity leads to efficient execution and lower power consumption. Most instructions are executed in a single clock cycle. Then, when we pass on to the load store architecture, MIPS primarily operates on data stored in registers. The memory access is limited to load and store instructions, which simplifies the processor design. So the third one is about the pipelining. MIPS processors use pipelining to execute multiple instructions concurrently. That is the parallelism. This involves breaking down the instruction execution process into stages. That is fetch, decode, execute, memory access, and write back. By overlapping these stages, multiple instructions can be processed simultaneously, increasing the performance. The fourth point is the instruction set. MIPS has a relatively small instruction set which can be categorized into three main types. R type, that is the register operations, example add, subtract, multiply. Then the second one is the I type, immediate operations. Example, load, store, add immediate. The third one is the J type, that is the jump instructions. Example, jump, jump and link. So the fifth key point is register file. Fifth key point is the register file. MIPS processors have a large register file, typically 32 general purpose registers. Each can hold 32 bits. This reduces the need for frequent memory access, improving the performance. MIPS versus other architectures. Compared to 86 processors, MIPS is similar and more efficient, but 86 has a larger software ecosystem and is more widely used for desktop and server applications. Compared to ARM, both MIPS and ARM are RISC architectures, but ARM has become more dominant in mobile and embedded devices. MIPS, however, has a strong presence in networking and digital media applications. So, where do we find the applications? That is the real world applications of this MIPS. Networking equipment, that is routers, switches, and network interface cards. In consumer electronics, we can find it in set top boxes, digital TVs, and media players. In automotive, engine control units and infotainment systems, they employ this MIPS. In embedded systems, microcontrollers and other small specialized devices are using this. In conclusion, MIPS is a powerful and efficient architecture that continues to be used in a variety of applications. Its simplicity, flexibility, and low power consumption make it a compelling choice for embedded systems and other devices where performance and efficiency are critical. Thank you. Hope you have understood. Hope you have enjoyed this video.